Hi everybody, we are in the week 2 of Algebra. What are we going to do today then? So, we're going to first look into laws of indices. Yes, by the end of this week, you should be able to use laws of indices to simplify algebraic expressions. You should be able to expand brackets and introduce brackets when necessary. You should be able to add algebraic fractions. You should be able to factorize and simplify algebraic fractions. You should be able to use changing the subject, very important topic. Yeah, you should be able to use changing the subject to find the unknown quantity. Yeah, if other quantities are given, how are you going to find the unknown quantity? Yeah, so to do that, you should be able to perform changing the subject. Then you should be able to factorize quadratic expression. And finally, you should be able to use all the algebraic skills to solve word problems. Okay, so before we go into the laws of indices, I want to be sure that you are good with powers. Yeah, powers of a number. Let's see what are powers of a number first before we see what are the powers of algebraic expressions. Yeah, so let's see what are the powers of a number. Okay, what is it? What does it mean? So consider 2 to the power of 4. What does it mean? You are using the power just for a simple reason. That is, you just want to represent this 2 times 2 times 2 times 2 is equal to 16 into a simple form. And that's why you use the power. So 2 to the power of is a simple way of writing 2 times 2 times 2 times 2 times 2 is equal to 16. Yeah, this is repeated multiplication. 2 to the power of 4 is a simple way of writing repeated multiplication. 2 times 2 times 2 times 2. Okay. Similarly, for example, 3 to the power of 3 is another way of writing 3 times 3 times 3. Yes, this is another way of writing 3 times 3 times 3. That's it. It is a simple way of writing. Yeah. So powers are used to show numbers that have been multiplied by themselves. Yeah. So that's why we use power. For example, if we say a to the power of n, that is, we are trying to get a general form. Yeah, in general, in mathematics, we want to generalize everything. Yeah, so in general, powers are of the form a to the power of n, where a is called the base and n is called the power. Yeah, so what's sitting in the bottom is base and what's to the power is the power. Yeah. So where a and number both are numbers, a and n are numbers here, and a is referred to as the base and n is the powers. Okay, so a is referred to as the base and n is the power. Got it? So here 2 is the base and 4 is the power. That's it. Yeah. Now we can write it in this way also. Numbers as a power. Yeah, so numbers can be written as a power, like for example 16 is a number. I can write this as a power. How do I do that? I can write it in the a to the power of n form as 2 times 2 times 2 times 2 is equal to 2 to the power of 4. Yeah, so from 16 I can write it as 2 to the power of 4, or from 2 to the power of 4 I can write it as 16. So it is vice versa. I can write it in any way I want, depending on the situation or convenience. Yeah, write each of the following as a power of another natural numbers. I want you to try this out now. Good. Now we saw in the previous example, the power was positive. Positive 4, positive 2, positive 3. The powers were all positive numbers, but powers can be negative. What does it mean, negative powers? Simple. 2 to the power of minus 3. What does it mean? It just means that it's a simple way of writing 1 over 2 times 2 times 2 times 2. That is nothing but 1 by 2 cube. Yeah, it is nothing but, this is nothing but 1 over 2. So it's just writing it in a simple way. Yeah, that's it. That is 2 cube. Yeah, 1 over 2 cube. That is a simple way of writing. Yeah, so here when you take this 2 cube to the numerator, the power becomes negative. Okay, so you can write this back. Yeah, so it's nothing but 1 over 8. You can use your calculator and find the decimal place. In decimal places you can write the number. Yeah, this is in fraction now. Okay, so in general, again, we like general terms, isn't it? So a to the power of minus n is nothing but 1 by a to the power of n. Yeah, similarly, 4 to the power of minus 2 is nothing but 1 by 4 square, which is nothing but 1 by 4 times 4 is 16, 1 by 16. 3 to the power of minus 3 is nothing but 1 over 3 cube. So it is 1 over 3 to the power of 3 is nothing but 27. Similarly, 2 to the power of minus 6 is nothing but 1 over 2 to the power of 6 is equal to 1 over 64. Yeah. Now, we saw positive powers, we saw negative powers, but powers can be fractional too, or roots. So you can say call it fractional powers and roots too. Yeah. So let's see that. But that's what I'm trying to say here. Okay. So it can be, instead of positive and negative whole number, it could be fractional powers. For example, here, what is the power here? The power is nothing but half, isn't it? The power is half. Half is a fraction, isn't it? Half is a fraction. Yeah, so this just means that because it is, can you see in the numerator it's 1? Yeah, here numerator is 1, denominator is 2. So this is nothing but another way of writing square root of 9. Yeah, so if it is 9 to the power of 2, that means 9 to the power of half is nothing but square root of 9. You can also write this as square root of 9 as like this. Yeah, that's a simple way of writing this. Yeah, as a power. Yeah, all these are same. What is this? If you simplify it, it's nothing but square root of 9 is 3. Good. Similarly, we can say in general, a to the power of 1 over n is nothing but nth root of a. Yeah, it's nothing but nth root of a. Nth root of a. So 16 to the power of half is nothing but the second or square root of 16. So this is nothing but square root of 16 or second root of 16, which is nothing but 4. And 8 to the power of 1 over 3 is nothing but cube root of 8, cube root of 8, or third root of 8, which is nothing but 2. 81 to the power of minus 1 by 4 is nothing but 1 over 81 to the power of 1 by 4. Look at that. Here the fraction was positive, here the fraction was positive, here the fraction is negative. When you have a negative term, you have another step to do. You have to first make it positive by bringing the number to the denominator in this way, and then you say that it is 1 over 4th root of 81, which is nothing but 1 over 3. Got it? It's the 4th root of 81. It's the second root of a, third root of a, 4th root of 81. In general, you can say it's the nth root of a. Okay, please get used to saying this. Okay, pronounce it and say it. Yeah. What if instead of a number 1 in the numerator, you have a number? Instead of 1, you have a number. Yeah, that means something like this, a to the power of m over n. So now you have m, a number which is not equal to 1, which is not equal to 1. M is a number which is not equal to 1. What do we do? It's the same thing. Yeah, 8 to the power of 2 over 3, for example. What does this mean? It's nothing but 8 over 2. You can say like this. Yeah, you can write it this way. That is 8 square cube root of 8. Or this is also correct. You can also write this as 1 by 3 whole square. You can write it like this too. That's fine too. This is nothing but and what is this? Cube root of 8 is 2. So you have 2 square. And this is nothing but 4. So you can do this way or that way. It's up to you guys. Yeah. So what did we do here? We took 1 over 3 inside the bracket and 2 outside. So we are going to first find the cube root of 8 and then square it. But in this case, what have I done? I have first taken the square of 8 and then taken the cube root of 8. So I have taken the square of 8 and then done the cube root of 8. Either way is correct, yeah? So in general, a to the power of m over n means nth root of a to the power of m, or I can say m times nth root of a power n. Not m times, sorry. Mth root of a power, nth root of a to the power of m. Okay? So either way, that's what we have seen here. For this example, we have seen both ways. Okay? That's what we, yeah. Similarly, you can do this in 2 different ways. Yeah, max can be done in n number of ways. So you can do this in any number of ways. Yeah. Here, be careful. Here there is a negative sign. So first, give respect to the negative sign. Bring that to the denominator and then do this process. Otherwise, you may make a mistake. Yeah. Negative sign, please be careful. Yeah. Now you can find one, either you can find the fourth root of 16 and cube it, or you can find the cube of 16 and find the fourth root. Either way is correct. Yeah. So here, what have I done? I've taken the hard way. Yeah. What have I done? I have done the cube of 16 and then found the fourth root of 16 in the denominator. Yeah. So this is a hard way. The easy way would be to find the fourth root of 16 and then cube it. Yeah, that would be the easy way. So you can do it in either way. Again, in mathematics, you always have a special case. So what happens if the power is 0? What happens if the power is 0? If you raise any number to the power of 0, the value is 1. So a to the power of 0 is 1, b to the power of 0 is 1, 10,000 to the power of 0 is 1. So for in fact, any non-zero number to the power of 0 is 1. So 1000 to the power of 0 is 1. 3 by 7 to the power of 0 is 1. Okay. So now I'm sure that you're good with numbers as powers. I want you to do this. Okay, pause the video and complete this exercise. Okay. Now let's see the powers in algebra. Okay. So often we get letters multiplying each other. For example, x times x, yeah? Instead of writing this, you can easily write this using powers. Just like 2 by 2 is 2 square, we can write x times x is x square. Yeah? How useful, isn't it? You can use powers to write it in much simpler way. Likewise, you can write x times x times x times x as x to the power of 4. How can you write this? Look at that. Here you have 2 different variables. You have x, and then you have y, y, y. You have 2 different variables here. So you can only add the powers for the same variable. So x squared times y cube. Be careful here, guys, because x and y are different here, isn't it? So you can't add the powers together. It's wrong. X to the xy to the power of 5 is wrong. Okay, because x and y are different variables. Yeah, so you can only add the powers if the base is same. If the base is same, if the base is same, you can add the powers. So if we have a to the power of n, then we can write a as the base and n as the power, just like how we did for numbers. But remember, the base has to be same. The base has to be same. That's it. Yeah, a is the base, n is the power. Okay, it's the same. Same terminology. You have to be careful. The base has to be same. Just like in numbers, you have to multiply with the same number. Yeah. So why don't you try this? Good. That's right. It cannot be simplified. Why? Why can't it be simplified? Because the base is different. It's already simplified. The base is different. You can't simplify it any further. Now, we have seen the laws of indices. Oh, no, we haven't seen the laws of, we are going to see the laws of indices. Yeah, we have seen what are indices. So let's see the laws of indices. Consider a to the power of m times a to the power of n. Okay, that's the first law. Let's see. Okay. So there are a number of laws that make the process of working with indices easier for us. Okay. So how are we going to do this? Let's take, what does this mean? A to the power of m means that you are multiplying a m number of times. Yeah. And you're multiplying a here, a to the power of n means you're multiplying a n number of times. That's a simple meaning. So can you see here, the base is same, a, it's the same. So a to the power of m plus n, that means you are multiplying a m plus n times. So you can write this as a to the power of m plus n. So that is why when you multiply a to the power of m times a to the power of n, we see that since the base for both of them are same, you add the powers. Since the base is same, you add the powers. So what is our first law of indices? When you have same base, you add the powers. When you have same base, if you multiply the bases, you add the power. Okay, similarly, you have other laws. Yeah, base has to be same. You have other laws. That's your first law. The other law is when you divide the bases. When you divide the bases, if the bases are same, this only holds when the bases are same. If the bases are same, then you subtract the power. You can also write this as x to the power of m divided by x to the power of n. It's the same thing, is equal to, because the bases are same, bases are x, you can write this as x to the power of, you can subtract the powers, m minus n. That's the same thing, okay? Both are same. Then you have the third law, which is nothing but x to the power of m whole bracket n. That means you're multiplying x to the power of m n times. You're multiplying x to the power of m n times. That is, you're multiplying x to the power of m times x to the power of m times x to the power of m times. You're doing it n times. You're doing it n times. So you can also write this as x to the power of mn. This clearly means that you are, when you have something like this, you multiply the powers. See, you multiply the powers. So you add the powers when the bases are multiplied. You subtract the powers when the bases are divided. You multiply the powers when you have something like that. And similarly, you can move this out, m out, n in. It's all the same because it's multiplication. Yeah, because you're multiplying the powers. And then the most important one, It can be fraction, just like in numbers, it can be fraction. So you can either write it as nth root of x to the power of m, or x to the power of m, take the root of it n times. Yeah, nth root of x to the power of m. So you can write nth root of x to the power of m, or you can write nth root of x to the power of m. Either way is correct. Then you have the base as fraction. Now the base is fraction. You have only one power. It simply means that x to the power of m divided by y to the power of n. That is, you're taking the power as common here. Yeah, you're just giving the power back to them. That's it. I want you to use the laws of indices, pause the video and do this problem. Yeah, that's right. Base is same. So you're going to add the power. You're going to use this law because base is same. That's right. The base is same. You're going to add the power. Yeah. Ooh, look at that. You have multiplication. You're going to use this. You have division. You're going to use this. And you have the power outside. You're going to use this. All three laws. Try it, guys. Good. Yes, base is same. So you can easily use these laws and you can simplify it. Good. How about this? Good. Very good. You can simply use this law. Yeah, that's right. Very good. How about this? Oh, you have to use the combination of this law. Yeah, here. Good. That's right. So suppose now we have an unknown quantity there. Okay. For example, we have 4 to the power of x is equal to 32. That means x is unknown. See, note, the power is unknown here. Yeah. What do? It simply means that because the power is unknown here, it simply means that you have to make the base same. For example, I can write this as 2 square to the power of x. I can write 4 as 2 square. And I can write 32 also in terms of 2 to the power of something. I can write 2 to the power of 5 as 32. Yeah. And now I can compare the base. Yeah. So what I'm doing here is when I have a power unknown, I just represent the powers with a common base. So something like this. But now I need only 2 as common base. So I'm going to write it like this. So now I have 2 as common base. So I can compare the powers. I can compare the powers. So 2x is equal to 5. So x is equal to 5 by 2. Got it? So x is equal to 5 by 2. That's it. Now, what about this problem? Here, the base is unknown. The base is unknown. In this case, what I can do is I can take the reverse of the power. Like I can reverse the power. Yeah. So for example, if I have x3 by 2, what I'm going to do is I'm going to take 2/3 on both sides. I'm going to take the reverse power, 2/3 on both sides. 4.1 times to the power of 2/3. Yeah. And what I'm going to do here, I'm going to cancel this because it's multiplication. If you have a power in this form, it's just multiplying the powers. Yeah. And then I get x is equal to 4.1 to the power of 2/3. I can't use my brain here. I'm going to use a calculator here. And using my calculator, I'll get 2.562. Yeah. Cool. Because it's not a perfect cube or something like that. Yeah. So we isolate the unknown by undoing any powers applied to it. That's the way you solve for the unknown expressions. Yeah. Now I want you to try these, okay? And I'll give you the answers once you finish it. Look at that, base is unknown. So I'm going to do like this. Yeah. Similarly, for this power is unknown. So I'm going to do like that. And then for the last one, I'm going to use my calculator, but again here, the base is unknown, just like this problem, base is unknown. So I'm going to take the reverse of the power, yeah? But before that, please make sure that you take care of the negative sign here, okay? That is why I put that 1 over x. First, take care of the negative sign and then reverse the power. And then reverse the power and sort it out. You can use the calculator and find the value. Okay. Okay. Now I'm going to ask you to do this, because now that you've done that, you will be able to do this, yeah? Okay, we have seen laws of indices. Now let's see how to expand brackets and introduce brackets and when to do that, okay? So this is the basic skill in algebra, yeah? To work with brackets, yeah? Very important it is, yeah? So when do you do that? Yeah, you simplify expressions by expanding or removing brackets. And the second thing is you use, when you are doing factorization, that is you'll be doing soon, factorizing expressions by introducing brackets. So for simplifying, you expand or remove brackets. For factorizing, you introduce brackets by identifying common factors. So let's first see simplifying expressions by removing the brackets. Yeah, let's see that. Oops, no worries. Simplifying expressions by removing the brackets or expanding the brackets first. Yeah. Okay, look at that. It's a beautiful expression here. What am I going to do here first? I can see some brackets here. What will I do? I will first remove the brackets. How to remove that? Expand it. So I'm going to multiply 2x with this. Then I'm going to multiply 2x with this term. Then I'm going to have to multiply these two now. So I'm going to do first 1 with this, then 1 with that. Then I'm going to multiply this term with this term. Then I'm going to multiply with this term to this term. Here, I just have to multiply minus with this term and then minus 1 with this term. If there is just minus, it just means it is minus 1. Again, same here. Be careful with the negative sign here. Okay, so first step, expand or remove the bracket. So it becomes 2x squared minus 2xy minus y minus 2xy plus 2 minus 4x. We haven't played with this minus yet, it's still there. Here I have taken the minus in, so minus 7x, minus minus plus. Look at that, we have some like terms here. You're going to group the like terms together, the next step. Simplify by grouping the like terms together. And you get this. Be careful with the negative sign, guys. Yeah. And then you simplify, take all the like terms. What has happened here? Minus 2xy plus 2xy is gone. Minus y plus y is gone. And I have two like terms which I can add. And then I get this. Cool. That's how you simplify expressions, by expanding or removing the brackets. Now, I want you to try this out now. Good. That's right, very good. Now let's see, when do you introduce brackets? Yeah, yes, we introduce brackets when we are factorizing expressions. And how do we do that? By identifying common bases. Let's do that. Yeah, factorizing algebra requires us to manipulate the algebra so that it becomes the product of a number of algebraic factors, usually involving brackets. That is, I'm just trying to say that in sentence. That's it. Algebra is nothing but algebra factor 1, factor 2, factor 3, and so on. As many factors you have. For example, look at this. Can you see anything common between each of these terms? Yes, you can. I can see that there is an x, x, x. There's a y, y, y. And they're all multiples of 3. So 3xy is common here. 3xy is common here. I'm just going to take this common factor out. That's what you do. For introducing brackets, you find the common factors and then you factorize it. Common factors in each term. And so you take the common factors. 3xy is common to all the terms here, common to each term here. And so you get this. You can factorize the expression as 3xy times 4x minus 3y squared plus 1. That's how you do. That's when you introduce brackets. So we have seen expanding brackets and introducing brackets. Now let's see adding algebraic fractions. What if we have a fraction? Okay, when we are doing simple addition in fractions with simple numbers, what do you do? So please be careful here. 2 is in the numerator and 3 is in the denominator. Please make sure you're well aware of these terms, okay? Because I use it often, yeah? Numerator, denominator, yeah? Okay, so when you're adding, you look for common denominator, yeah? When you're adding fractions, you look for common denominators. For example, 2 over 3 plus 7 over 3 is nothing but 9 over 3. What did you do here? Because the denominators are common, you don't have to do much. You can easily add it, yeah? So you get 3 times 3 is equal to 3. 9, and 9 divided by 3 is 3, yeah? But here I'm trying to show you what if the denominator is not common, okay? Let's take an example for that, yeah? So look at that, 2 and 9, the denominator is not common. What can you do? You take the common factor, 2 over 9, the simple way, yeah? That's what you use for algebraic fraction while adding algebraic fractions, yeah? And then multiply 3 with 9 plus 7 times 2. Okay, 3 times 3 times 9 plus 7 times 2. And then add the numerator, multiply the denominator. And that's how you add fractions in numbers. This is the same idea we use for algebraic fraction. So why don't you try this out first? Good. So let's add algebraic fractions now. How do we do this? See, these are all algebraic fractions. These are all algebraic fractions, okay? These are all algebraic fractions. Algebraic fraction is nothing but you have numbers, letters, as we saw in the last week, numbers, letters, and mathematical operations, yeah? Sometimes it is necessary to combine several algebraic fractions to form a single fraction. So for example, if I have two algebraic fractions here I am subtracting them, yeah? How will you do? The denominator is not same. So what can you do? What did you do here for when the denominator is not same? You multiplied the denominators and then in the numerator, you multiplied the first numerator with the denominator, the next one, yeah? And then do the same thing here. Yeah, that's the same principle we're going to use here because it's a common factor, yeah? So we find the common denominator. How can you find the common denominator? Just multiply the denominator for both x minus 2 times 2x plus 1. And then how many times does x minus 2 go in that? 2x plus 1 times. So 2x plus 1 times x plus y. Similarly, how many times does 2x plus 1 go in this? X minus 2 times. So 3 times x minus 2. Be careful with the negative signs, okay? Be careful with the negative signs. Then look at that. What do you do when you see a bracket? You remove the bracket. When you see a bracket, for simplifying, you remove the bracket. And that's what you're going to do here. You remove the bracket and simplify it. But please make sure you don't do that for the denominator. Just leave the denominator in factors. That looks beautiful already, yeah, because you will be using it further in real life and solving real problems. This is very important. You leave it as factors because it will be useful in further maths, yeah? Okay, so leave the lowest common denominator in factorized form. You don't have to simplify that, yeah? Only the numerator, yeah? Okay. Factorizing and simplifying algebraic fraction, yeah? Let's do that now. So we can also simplify some algebraic fractions by factorizing both the numerator and denominator separately. There are problems like that too. Yeah. Okay, let's see an example probably, yeah, to do that. Yeah. So simplify, look at that. Here, what do? You can see the common terms. You can see clearly there are common terms. What can you do? You can factorize the numerator separately, factorize the denominator separately, and then simplify. So for that, what do? Look for common term. Look for common term. I can see some common terms here. X in the numerator, X in the denominator. But I'm going to do it separately. Numerator first and then denominator separately. Yeah. So in the numerator, X is common. In the denominator, X square is common. So I'm going to say take and make it into factors. So there's the factors X. Yeah. Okay. So factors. So this is a factor and we have factors. And now we can simplify it. So this is a quadratic, which we're going to see soon. It's a quadratic expression and you can make it into factors, factorizing quadratics, and then you can solve it. We will look into it soon, yeah? And then what can you do? You can simplify it. You can cancel it. Because x square is nothing but, it's something like that. X square is, sorry, x times x. So you can cancel it. And this you can cancel it. So you have 2x minus 7 over x. Okay, now try this out, guys. Yeah, you have four problems here. So please try that. Now, what is changing the subject here? What is changing the subject? Yeah, let's see that now. Yeah. So let's first do the changing the subject for formula. And then we'll look for an expression. Okay, how to do it for an expression. It's almost similar. Yeah, formula. We have done recently this 2 weeks ago. What is this? Yeah, that's right. Yes, it's a simple interest, isn't it? No, compound interest, sorry. It's a compound interest formula, isn't it? No? Yes. The subject I, the interest, because it appears only once by itself. How do you do that? Suppose we now want the formula to show P as the subject. You want P as the subject. That means you want P in the left-hand side. Let me make it clear here. This is left-hand side is equal to right-hand side. Left-hand side equal to right-hand side, yeah? So when you have something like that, and if you are given the value, for example, R is equal to 2% and P is equal to 20,000 pounds or 200 pounds. Let me take 200 pounds, yeah. 200 pounds, and you don't know I, then you can use this formula. But if I say that I give you the value of I, for example, I give I is equal to 100 pounds and R is equal to 3%, and then now you want to find the principal amount P, then you have to rearrange this formula such that you have on the left-hand side P and all the rest on the right-hand side. Then you can substitute I in that, R in that, and find the value of P. Is that okay, guys? So that is called changing the subject to the term which you are going to find. Yeah. So you're going to, because you want to use this formula to find P, so you will try to bring P to the left-hand side. So that is called changing the subject. Okay. It's a very important exam style question. Yeah. But it won't be directly given to you. It will be in the form of a word problem also. Yeah. To achieve this, we need to rearrange the formula using the rules of algebra so that we have P by itself. So let's rearrange this, yeah? How do we do this? This rearrangement is done by performing identical operations to both sides in order to isolate P by itself and bring P to the left-hand side. Let's do it then, yeah? Let's do it together, this one, and the next one, you can do it as homework, yeah? So starting with this, firstly square on both sides, because I can see a square root here. The best way is I want to have this p out of this bracket, the square root. So I'm going to square on both sides, and then I multiply both sides by 100 because I want to remove the denominator now. First square root is gone, now the denominator is gone, and now I don't want this bracket because I want p to be free of brackets so that I can isolate p, yeah? And then I divide by r. Now what happens? P is almost alone now, yeah? Now you can subtract 1 on both sides and then p is free. That's it. And there we got the formula. Now we can substitute the value of I, substitute the value of R, and find the value of P. So that's how we change the subject from I to P. So we can calculate P now. Okay, so note that we have written this with P on the left-hand side, but it isn't necessary to do this. It is just for convenience, okay? I like to write everything on left-hand side, so I bring it to the left-hand side, but there is nothing wrong, okay? You can put it in this way also. There's nothing wrong in writing 100 I square by R minus 1 is equal to P. That's fine. Okay, now try this out. Here I have given you two questions where I'm giving you the value of L, I'm giving you the value of G, the acceleration due to gravity, and the length of the pendulum, yeah, simple pendulum. I'm asking you to find that time period T, the value of T. So you just have to substitute this value and find the value of T. And then I'm asking you to change the subject to G. That means I want G in the left-hand side and I want you to calculate, give me a formula, not calculate, give me a formula for G. What is the formula for G? Try it, guys. Okay, now we have seen changing the subject in the case of formula and we know the importance of it. Let's do it for algebraic equations. That's important too, yeah? When in real life to solve problems, we use algebraic expressions and equations, yeah? We use equations, and by changing the subject, we can find the value of the unknown quantity. So it's very useful, yeah, in real life. Let's do that. So let's consider this expression. I mean, this is not an expression, sorry. This is an equation because can you see the equal to sign? This is what I was saying. We all make that mistakes of accidentally saying expression, yeah? This is an equation. You can see that you're balancing, you're equating two terms, I mean, two expressions, yeah? You're equating two expressions, so it is an equal equation, yeah? So suppose we wish to change the subject to X. I want X on the left-hand side. What am I going to do? I have to first step, get rid of the denominator. First step, get rid of the denominator, yeah? So I'm going to achieve this by rearranging the equation, but this time we have two terms, so you have to be careful. So I'm going to multiply both sides by 3 times x plus 1. I'm going to multiply, so y times 3x plus 1, because I have multiplied both sides by 3x plus 1. I'm going to multiply both sides because I don't want the denominator. I want to get rid of the denominator first. Gone. So I get this. So I get this. Then, oh, what do you do when you see a bracket? What do you do when you see a bracket? You remove the bracket. And you remove the bracket. Expand. And now what do you do? Look for the like terms, yeah, but you want x on the left-hand side. I'm going to take the other things on the other side, x on one side, so that I have like terms. I bring x this side. Now I can see that this term has x, this term has x. So I'm going to write x as common, yeah, and bring all the other things on the other side. Now I have x and x terms here. So I can write x as common factor, and I'm bringing it back. Look at that, how beautifully we are doing it, yeah? Here we removed the bracket, now we are bringing back the bracket because we want to factorize. Okay, here we simplified, then factorized. And then that's, now you want just x. What can you do? Divide both sides by 3y minus 1. And then you can get rid of this. It gets cancelled. And you get 1 plus y divided by 3 minus 1. So you're dividing both sides by 3y minus 1 and you change the subject to x. That's it. Now I want you to try these three, yeah? Good. Now let's see how to factorize quadratic expressions, yeah? Okay, quadratic expressions are of this form, yeah? Let's do that. Algebraic expression of the form ax squared plus bx plus c. Be careful, guys. This is the general form for the algebraic expressions. You should know that. Is known as quadratic. It's very important. Please, we are going to use this term a, b, c very often. So please make sure that you use the same general form. Yeah, you can use any letters, but for our convenience, let's use the same terms. Yeah, so that we know what we are talking about. Yeah. So ax squared plus bx plus c is what we are going to use. Okay, you can also say px squared qx plus pqr. Yeah, px squared plus qx plus r. You can say that. That's nothing wrong. Just for our convenience, we are using this term. Yeah. So where a is the coefficient of x squared, b is the coefficient of x, c is a number constant. It's a number constant. Okay, it's a constant number. It's a constant value. Okay. For example, for the quadratic x squared minus 4x minus 12, how do you factorize this quadratic? Okay, coefficient of x squared is 1. Can you see? If there is no number attached to it, that means it's just 1 times x squared. So it is 1. A is 1 here. Good. What is b here? Compare this expression with this expression. This is an expression, no equation. Okay, there's no equal to sign. We are not equating it to anything. So it is an expression. So what is the coefficient of x? Minus 4. Yeah. So minus 4 is the coefficient of x. So b is minus 4. What is the coefficient of, sorry, what is the constant c here? Minus 12. C is minus 12. Got it? Yeah. Now let's see. Okay, algebraic expressions of the form ax plus b, x squared plus bx plus c. You should remember that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Yeah. Okay. Quadratics can be factorized in n number of ways. You can do it your way. Okay. For example, for this x squared minus 4x minus 12, this is one very simple quadratic. So you can just look at this and then factorize it. It is possible in this case. You don't have to worry about it. Yeah. So you can just say that, yes, x squared minus 4x is nothing but x minus 6 times x plus 2, because minus 4 is 6 minus 6x plus 2. Yeah, plus 2x. Yeah. So you can factorize it. I'm just writing this term, the b term, as minus 6x plus 2x, yeah, and then factorizing it. Similarly, x squared plus 7x plus 10, I can say easily, yes, it is 5x plus 2x. So I can factorize it. X squared minus 6 is much more easier. X is a common factor here. So I can say, take x out and say x minus 6. Again, here, what is it? No constant term on the coefficient of x squared. The c term is 0. Okay, there's no constant term. Now, x squared minus 9, what does this look like to you? Do you remember this? A plus b times a minus b, this formula when you learned it at school, is nothing but a squared minus b squared. That is what is here. Here a is x, b is 3. Yeah. So x minus 3 times x plus 3. A plus b times a minus b. It's not the same a and b. Okay, guys, don't get confused. That's different. Note that the quadratic term has no x term. Here the x term, this is missing. So it's something like this, x squared plus 0, 0 times x minus 9. That's what it is. So because b is 0. Okay. But if there is complicated problems where it is not easy to factorize it, I would prefer to use this method. You can use your method, it's all right, completely all right. But if you think that this method is easy, please go for it. So by multiplying together the coefficient of x squared, what is the coefficient of x squared? Is a. A is equal to 1. And what is the constant term here? C. C is equal to minus 12. What I'm going to do here is I'm going to multiply A and C, AC, and I get minus 12. So now I'll identify two numbers, any two numbers that will multiply to give C. That is C is equal to minus 12. Yeah, that should multiply to give C and should add to give B. Should add to give minus 4B. So I have to find out all the terms which multiply to give C. For example, 2 times minus 6 minus 2 times. I'm going to use all the numbers to find that which two numbers multiply to give minus 12. Yeah. Then I can do minus 4 times 3, minus 4 times 3. Then I can do 4 times minus 3. What else can I do? 12 times 1. Oh no, minus 12 times 1. Or 1 times minus 12. And that's all I think, isn't it? Now I have to check which of these will add to give minus 4. So 1 plus 1 minus 12, if I add, I'll get minus 11. So no, I don't want this. If I add minus 12 and 1, I will get, I've done the same thing, yeah, so I should do minus 1 plus 12 here. So I get plus 11, but that's wrong. I don't want this. Here I get minus 11. I don't want that. I want minus 4. It should, when I add them, I should get minus 4. 4 minus 3, 1. No, that's not correct. Minus 4 and 3, if I add, I'll get again minus 1. No, I don't want that. Minus 2 plus 6. Oh, no, I got 4. I want minus 4. Plus 2 minus 6 minus 4. That's my number. These are my numbers, 2 and minus 6. So I will go for 2 and minus 6. So I try all the combination, then I'll choose minus 6 and 2, because when I multiply them, I get minus 12. And when I add them, I get minus 4b. So when I multiply two numbers, I should get minus 12. When I add the same numbers, I should get minus 4. So first C and then B. That's it. So by rewriting the above quadratic expression, I can write minus 4x as minus 6x plus 2x. I'm taking the help of this. Minus 6x plus 2x, because this is nothing but minus 4x. So I write the same term, x squared minus 6x plus 2x minus 12. That's it. That's how I can make factors. See, now by factorizing, I can take x common, x times x minus 6 plus 2 times x minus 2 times 6 is 12. And there it is. So I have the common factor. I can take it out and then say that the quadratic can be factorized using the common factor. Perfect. That's how you do. So this is very useful when you have complicated expressions. Yeah. So I want you to try this. Any method, yeah, use your own method. It's up to you. If you find that method easy, please use that. Yeah. What if the coefficient of x square is not 1? This is when that method will be very, very useful. Yeah. So for example, here, what is a? A is not 1. A is, see, I'm comparing this with this, the general expression with this expression. Yeah. So a is 6 and b is minus 11, c is minus 10. Yeah. So with quadratics like this, there are several ways to factorize. So first you observe, you can do it. Some of you can do it, I'm sure. Yeah, it's very easy to do for some of you. For some of you, sometimes you may get stuck. Even those who can do it all the time can get stuck with observation. Yeah. So sometimes because it's not obvious, yeah, it's not seen obviously, yeah, how to factorize it. Yeah. So investigating the factors for A and C, and remember, this is that. So compare that and use the methodical approach, which we just did now, and then solve the problem. So let's do the same method and try to solve that using that simple method. Okay. So let's do the same example. Okay. Here A is not equal to 1. And I know that A is 6, B is minus 11, C is minus 12. So what is AC? A, C, B. What is AC? 6 times minus 10. It's minus 60. Perfect. Now I have to identify two numbers which multiply to give minus 60. And I have to add that two numbers to get B, minus 11. So let's start doing it. So I'm going to do 10 times, I need to get minus 60. So minus 6. And what else can I do? 12 times minus 5. Or the other combination is also correct. So I have minus 10, 6, and minus 5, 12. And I can do it with 4 also, isn't it? 4 times, minus 4 times 15. I can do it 4 times minus 15. And it goes on actually. Then I can do it with 3. 3 times minus 20. And minus 3 times 20. Now what do? You have seen that all this will give you, all these products will give you minus 60. But which of these will give you minus 11 when you add them? That's what you have to figure out. Which of these, when added, will give you minus 11? When added, will give you minus 11. So I can clearly see that minus 4 and 15. That will give you plus 11. 4 and minus 15? Yes, it will give you minus 11. So I'm going to choose that. Okay, I'm going to choose that. And then, see, I'm going to choose that because it makes sense for me. Minus 15x plus 4x minus 10. So I'm going to write minus 11x as the sum of 4x and minus 15x. And then I factorize it. And I see the common factor 2x minus 1. I take the common factor out and 3x plus 2. That's how I factorize a quadratic expression. Okay, so you can do it the other way also. There's nothing wrong. You can write 4x here and minus 15, just like how I've shown here. Yeah, 6x squared plus 4x minus 15x minus 10. That's correct too. You will get the same answer. Yeah, it's max. That's the beauty of max. 3x plus 2 times 2x minus 5. Good. Okay, this for you. Okay, guys, you try this out. Yeah. The last one, using algebra to solve word problems. Yes, this will be the main, I mean, most of the exam style questions will be like word problems, yeah, which you should be able to do it. Yeah, we will do some word problems in seminars. Yeah. Let's do one word problem now in the class, just for a taste of it. Yeah. So consider the following problem. Jasmine's mother is 28 years older than Jasmine. That's your first sentence in the statement. If 3 years ago, Jasmine's mother was exactly twice her daughter's age, then how old is Jasmine now? First step, do not panic. Second step, solve the problem. Okay, how are we going to solve the problem? Read the question, break the question into parts, convert the English into max. Convert the English into max. Jasmine's mother is 28 years older than Jasmine. Convert it into max. If 3 years ago, Jasmine's mother was exactly twice her daughter's age, make it into max. How old is Jasmine's now? You can either pause this video and try it out and then listen to my lecture, or you can listen to the lecture directly. Yeah, it's up to you guys. So one way of solving this is to translate it into mathematical language. That's what I was trying to make it clear. Please, guys, make it into max. So 3 years ago, because we are talking 3 years ago, and we are talking about now, 3 years ago and now, in between 2 years ago and 1 year ago. Yeah. Now, what is Jasmine's age? Let's imagine that it is X. 3 years ago, Jasmine's mother was exactly twice her daughter's age. Okay, so let me try that. So mother's age is, she is 28 years older than Jasmine. That's right. So if Jasmine is X years old, her mother is X plus 28. Now, 3 years ago, Jasmine was X minus 3. She was X minus 3 years old. What will her mother be then? Less than this, 3 years less than this, isn't it? So she will be X minus 3 plus 28, or I can say X plus 28 minus 3. It's the same. Yeah, I can also say that. There's nothing wrong in it. Yeah, I can also say, it's the way you guys are thinking. Okay, there's nothing wrong in it. I can also say X plus 28. It's the same. Minus 3. But 3 years ago, Jasmine's mother was exactly twice her daughter's age. From here, yeah? So X minus 3 plus 28 is equal to 2 times what Jasmine was at that time. Or I can say X plus, that is my equation. See, I got a linear equation here. Now I can solve it to find the value of X. That is, find Jasmine's age. So I can also write this as X plus 28 minus 3 is equal to 2 times X minus 3. Yeah, that's also correct. Yeah, both are same. So that is the equation we have to solve. Simple, isn't it? This is your equation to solve. And then you can solve the equation. How do you solve it? Take the like terms together. And how do you do that? By changing the subject to X. You want X on the left-hand side. You want X on the left-hand side. You start working on it. So bring all the other terms to the other side, bring the like terms together and solve it. So you're isolating X now, the unknown variable. So you have X plus 25 is equal to 2X. Now bring 2X to this side and 25 to that side, right-hand side. You can do it the other way also. That's perfect. Yeah. So X is equal to 31. So you get X is equal to that 31. That is Jasmine's age. Okay. So that's how you solve. Okay. With the help of algebra. We'll do more problems in seminars. Okay. So we have seen how to solve word problems. So see you in the seminar. Please try to do the problems on the textbooks and worksheets. And let me know if you have any trouble. Yeah. Thank you.